Everybody, we have effectively filtered out all those people that think they're imagers down to the hardcore EEG people. So this is, I think, good progress. And so today we have Casey Gilmore here, who's also from neurobehavioral research, just like his wife, Jasmine. And he did his PhD at the University of Georgia with Brett Clements and probably a few other people there, and then a postdoc out in, I guess you were focusing, you did a bit of work on twins.
Yeah, Twin City.
And, of course, where do you do twins?
Minnesota.
Yeah. The Minnesotans should know. And now he's in Hawaii for him, working on a neurobehavioral research Inc., which both apparently does SBIR, as we learned last night, and a few other more interesting things. And they are very interested in many of the things that we are interested in, which is biomarkers of things like prediction of outcomes. And I think really taking imaging to the level where it has some clinical utility. That is, does it help to collect this data? Does it actually just differentiate groups? Does it help to do this? And where's Jeff? Loin should be here because he wants to do everything with EEG. I'll have him for that. And so without further ado, Casey's discussion or talk today will focus on theta event-related synchronization as a biomarker for a morbid effect of alcoholism on the brain. So please join me in a good EEG rapper. Same family.
Thank you. So first of all, I just want to thank everybody here who we met and haven't met for being so welcoming for us, campus especially. It's really an honor to come out here and be able to talk to you guys. So, but the one thing though, to have a complaint about, is that we were told that New Mexico has like 360 days of sunshine. And the one day we're here, it rained.
Did it rain?
It did rain, yeah. This morning. Or you could blame it on us. We brought it from Hawaii.
Mutually exclusive, though.
Yeah. So today I thought that I would talk briefly just to some of the recent results we've had looking at neurobehavioral research. We mainly focus on alcoholism, and in particular, alcoholics who have been able to achieve and maintain abstinence for either some short period of time or even a multi-year abstinence. And I've been focusing, part of my stuff is focusing on looking for biomarkers for either phenotypic markers for genetic predisposition to alcoholism, or at the other end, right? So markers for use, possibly. And I'll be talking today about a particular EEG-based measure that seems to be, based on some of our results that we recently gotten, seems to be related to use, and it could potentially be a biomarker for use of alcohol. So just as some background, I sort of assume you guys know a lot. Maybe about more than me, but I'm interested in electrophysiological biomarkers, so stuff based in EEG and EEG. Right? Yes, I don't know if you guys saw Jasmine's talk yesterday. She's talked about some MRI stuff. I assume most of you know EEG or work with EEG here. Is that true? Okay. Like Ken said, we probably weeded out all the fMRI people here. Just kept it good. But it's kind of funny because Jasmine does fMRI and I do EEG, so it's been said that we have a mixed marriage. But anyway, so we'll be looking at I'll be looking at EEG-based parts for alcoholism. So just as some background, you guys probably are well aware of this, but just for those of you who aren't, one of the most robust findings related to alcoholism is the P3 event-related potential. It's been shown 20 plus years, consistently shown that alcoholics have reduced amplitude of the P3 ERP. And it's also been shown, of course, in relatives of alcoholics and kids of alcoholics, those at high risk, genetically high risk to become alcoholics. So it's a pretty robust, consistent finding. More recently, within the past 10 years or so, we started looking at time frequency decompositions of ERP, and it's also been shown that if you decompose the ERP into its constituent frequency parts, in particular delta and theta that underlies the P3, that those time frequency components are also reduced in alcoholics and also reduced in relatives of alcoholics. You may be familiar with these kind of figures. Actually, these figures are not our data. It's a sort of prototypical. I got these from some code papers. They're sort of prototypical examples of the kind of figures you'll see and the kind of data that you'll find in relation to alcoholism, family history related things. These are typical time frequency heat maps, right? So, and this one shows that those at high risk have lower amplitude or lower power of theta time frequency power compared to those at lower genetic low risk for alcoholism. So we can say fairly confidently that P3B, ERP, and particularly the evoked time frequency theta power, and of course by evoked I mean that which is consistently time locked, phase locked to the stimulus. Those have been shown to be putative endophenotypic markers for the reduced amplitude of which are putative endophenotypic markers for alcoholism, genetic predisposition to alcoholism. So one question that you may come up with, that has come up, that we first addressed in relation to this, is given that time frequency decompositions are essentially sort of more alternative view of ERP and a sort of a more fine-grained view of ERP, right? So you break the ERP down into its sort of constituent frequency components. Do these time frequency components, could they potentially be sort of more powerful biomarkers for alcoholism than the P3, P3 amplitude itself, P3B amplitude itself? And by more powerful, I mean, could they account for unique variance, right, or independent variance in alcohol versus control group membership above and beyond that, which is kind of accounted for by P3B. And in particular, like I said, we focus on abstinent alcoholics. So we looked at this question. That question has been addressed in alcoholics, in sort of younger, early adulthood alcoholics. And it's been shown, been suggested that they perhaps do, time these components may perhaps do account for some unique variance above and beyond what you can account for with P3B, ERP by itself. But we were interested in looking at this in long-term abstinent alcoholics. Right? And by that I mean alcoholics who have become abstinent, been able to achieve abstinence and also maintain it for multi-years. At least our definition is 18 months or above. And some of them have been abstinent for 10 years, 15 years. So what we did to address this question in long-term abstinent alcoholics is, I forgot to mention that you probably know that P3B is recorded in typically in an oddball task and in response to the targets in an oddball task. So that's what we did. We gave an oddball task to the participants, a group of long-term abstinent alcoholics and a group of non-alcoholic controls. It was a standard visual oddball task, and then we looked at the ERP in response to targets. And in order to compare the amounts of variance that could be accounted for by each of the measures, we used logistical regression analyses. So we took the P3B amplitude, measured that basically, taking a peak measure of P3B. We also looked at the evoked theta power, which has been shown to be putative endophenotype for alcoholism. And by the evoked theta power was measured by doing time frequency decomposition on the ERP, the average ERP itself. So in that case, you're sort of attenuating the non-phase locked stuff and accentuating the stuff the activity that's phase locked to the stimulus consistently across trials. And that's been shown to be to underlie the ERP and also to be an endophenotypic marker. Now we also looked at induced theta activity. You're probably aware that is the part of the activity that the brain responds that is not consistently phase locked to the stimulus. And we looked at that because there was some preliminary previous results in our lab showing that there could potentially be important alcohol-related information in the induced activity. And this actually, not to our knowledge, never been shown before. So we wanted to see if, first of all, we could see the effect in long-term abstinent alcoholics, if there was a difference between alcoholics and controls in this induced non-stimulus phase locked activity. And also, how it related to P3B and evoked beta in respect to how much variance it could account for in group membership. And the way to measure induced theta, or the way we did it, this pretty standard way, is to take the average ERP, and then for each trial, each target locked trial, basically subtract the average ERP from each trial. And what that does is it leaves you with the non-stimulus phase lock. You're subtracting out the stimulus phase locked activity, and it leaves you with the non-stimulus phase locked activity. So the stuff that's evoked, not evoked, but elicited by the target, but not consistently phase locked to the stimulus across trial. Okay. And then the way you measure that is what's called theta, or event-related synchronization. We're focusing on theta because that's where we've seen the effect. And basically what you do is you take a post-stimulus activity, which is basically the ratio of the post-stimulus activity to some part of the pre-stimulus activity. And so event-related synchronization shows that there's an increase in power in specific frequency bands relative post-stimulus relative to pre-stimulus, right? Now, the flip side of that is event-related desynchronization, you probably heard of. That's a decrease of activity post-stimulus relative to pre-stimulus. But we're focused on synchronization because that's what happens. Okay? So this is, at the top we have the ERP, pretty straightforward. ERP to the targets, average for the controls, NACers and non-alcoholic controls, LTAA, long-term abstinent alcoholics. Of course, time on the x-axis, amplitude of the ERP on the y-axis. And as been shown before, the alcoholics have reduced amplitude P3, and it's parietally located. You see the topographic maps on the right. Doing the two-time frequency decomposition, and by the way, if you're familiar with Ed Burnett's psychophysiology toolbox, that's the one I used, and I used the Cohen's class reduced interference distribution decomposition method. There's many different methods, FFT-based, short time to weight transform-based wavelets. The RID has particular advantages, so I use that one. We can talk about that later if you want to do this specific information. So basically, I took the time frequency decomposition of the ERP, the average ERPs, sort of bandpass filtered in theta band, and then for this series of studies, what I did was basically a sort of a region of interest, or a time frequency region of interest. So I sort of visually saw areas on the time frequency surfaces where activity was, created a region of interest, and took the average, so the mean power within that region of interest, and that was the measure that I used. So again, you see the evoked activity, this phase locked activity, again, reduced amplitude in the alcoholics. That's consistent with what's been shown before. Parietally located, that's consistent with what's been shown before. Now in the induced activity, this is where all the cool stuff is, fortunately. Same kind of thing, the two time frequency decomp, but this time on, remember, subtracting the average ERP out of each trial and doing the time frequency decomp on each trial and averaging that. So that leaves you with the non-stimulus phase locked activity. Doing the same kind of thing, sort of region of interest, pre and post stimulus, that's what's indicated by the black dash boxes there. Take a ratio of those, and that gives you the theta event-related synchronization measure. It's more frontal essentially located. That's consistent with what's been shown with theta before. But the cool and interesting finding was that as opposed to being reduced in alcoholics, which is the typical finding you see in ERPs and evoked theta measures, we actually saw that the induced activity of the event-related synchronization was higher in alcoholics than it was in controls. And that's indicated by the bar graph here on the bottom. That's the event-related synchronization measure. So it was higher, significantly higher in long-term abstinent alcoholics than it was in controls. So again, theta event-related synchronization was increased in alcoholics, long-term abstinent alcoholics versus controls, which is opposite in direction, like I said, to what you typically see in the average evoked event-related activity. So that's sort of a novel, interesting finding. And also in relation to the amounts of comparative variance that it accounts for in the logistic regression analyses. We showed that in the induced data, the event-related synchronization was sensitive to differences between long-term abstinent alcoholics and controls. So it could differentiate the groups, which is good. But that was also independent of variance that was accounted for by the P3B and the Evoked data, right? So P3B and Evoked data, if you put those in the regression analysis together, you compare the fits in the models, neither one accounts for any sort of independent variance in the presence of the other. Whereas if you put the induced data, the ERS measure, in the regression models with either of the other two, P3B or Evoked data, it does account for unique sort of independent variance above and beyond what the Evoked measures account for, right? So what this shows or suggests is that this induced data effect is dissociable from the endophenotypic effects that we see, right? That are associated with the Evoked measures, which could suggest that it's not related to genetic predisposition per se. It's potentially related to something else, such as use. Right? So is it not since it's independent of the pure endophenotypes, it accounts for independent and unique variance, and it also differentiates the groups. It could potentially be a biomarker for the effects of alcohol use on the brain. So let's take a break here and talk about what data means. Right? So if it is a case that is a biomarker for the effects of alcohol use on the brain, well, what effects? So it's been shown that in healthy non-clinical populations that induced theta activity, it's been associated with working memory load, it's been associated with allocation of attention to task demand. So for instance, using in-back tasks, they've shown that induced theta ERS typically increases with increasing memory load. So for instance, compare the theta ERS between a 0-back condition and a 1-back condition and a 2-back condition of the in-back, it will increase as the working memory load increases. Right? And it's also been theorized to reflect sort of the activity in cortical hippocampal loops that are involved in processing task-related stimuli, such as the targets and oddball task. Right? And then retention to working memory, which in P3B, the activity related to the targets and oddball task is essentially related to working memory context updating. Right? So ERS is related to the retention of working memory for the anticipation of further task-related requirements. So that's the sort of the activity, the brain activity that theoretically is indexed by this measure that we're looking at. And of course, alcohol use has been associated with working memory and attention deficits. It's also been associated with neurodegeneration in the hippocampus and in areas like the superior frontal cortex. It's also been shown that these cognitive deficits may recover with extended abstinence. Right? So we see these cognitive effects in alcoholics, but if they achieve and maintain abstinence, they typically regain, at least partially, right, some of these cognitive deficits that you see in actively drinking alcohol. Right? Well, this suggested that the increased event-related synchronization in the alcoholics versus the controls suggests that they may be engaging the working memory and attention process to a greater extent, right, to perform the oddball task, because they performed well on the oddball task. Right? Now, keep in mind the oddball task is relatively easy, right? It's not too hard to respond correctly to the targets. So, using the oddball task itself, you can't really say that's working memory versus attention problem. That's the underlying thing here. But it suggests even in the presence of successful performance, we see these brain differences. Right? So it suggests that brain differences are sort of being engaged to a greater extent, right, in order to be able to perform the task. Okay, so if that's the case, we thought that we'd look at this in our short-term abstinent alcoholics. Right? We have a group of alcoholics who have achieved and maintained abstinence, but for a shorter period of time. They just sort of recently initiated abstinence and are between 6 and 15 weeks of maintaining abstinence. Now, this we thought this would tell us is that we hypothesized that if it's the case that it's sort of the Theta ERS's measure of these cognitive deficits, that they may be recovered with extended abstinence, that we should see the same effects in the short-term abstinent alcoholics, however, to a greater magnitude, right, to a greater degree, right, because they just stopped drinking, right? So if we think that it's a measure of these cognitive deficits that are regained after abstinence, then we should see a higher Theta ERS in short terms, and that should sort of resolve as the abstinence is maintained over a long period of time. But of course, as long as the groups don't differ on some other relevant measures, right? Such as severity of alcohol use problems or density of family history of alcohol problems. And I'll tell you right now that they don't. Right? Short-term abstinent alcoholics and the long-term abstinent alcoholics don't differ on the severity of use measures, various measures of that, and also on the proportion of first-degree relatives who had alcohol problems. So they're basically they're equalized on those measures. So if we then see differences in the Theta ERS measure, then that would sort of lend more evidence that it is actually a marker of these cognitive deficits that may be regained after extended abstinence. So we did that. We used the same oddball task, looked at the activity of targets, and then we compared using the same groups from before, the controls and the long terms, and we added the short terms and did sort of an over and compared the Theta event-related synchronization measure between those two groups. And what we found was that indeed both alcohol groups, the short terms and the long terms, had increased. It's a little easier to see the part. Had increased Theta event-related synchronization. So compared to controls, both the alcoholic groups had increased. And beyond that, the short-term abstinent alcoholics, sort of as we hypothesized, showed a greater magnitude of the increase of Theta event-related synchronization, right? Which is shown here. That's what I just said. Right? So that would suggest that, or lends more evidence to the proposition that this larger Theta event-related synchronization that we see in the short term and the long term, it may be a reflection of some sort of compensatory mechanism, right, for the attention and the working memory impairments that we see in alcoholics. And it also is concomitant with the recovery of these cognitive deficits in long-term abstinent alcoholics is concomitant with this sort of recovery of this Theta event-related synchronization measure. Right? It's high in those people who have just stopped drinking, recently initiated an abstinence, and it sort of becomes more normal, right? As the people maintain abstinence for a longer period of time. So it could be a marker of this compensatory mechanism that also may partially, at least partially, because it doesn't go back. You know, the long terms weren't. They differed. They had significantly higher ERS than the controls. Right? So it didn't completely recover. So it may be partially recover with extended abstinence. So what we're working on now, and what we'd like to work on coming up. So we also have groups of what we call treatment-naïve actively drinking alcohol. These are people in the community who meet criteria for dependence, alcohol dependence. However, they've never sought treatment. They wouldn't claim to be alcoholics, right? But they're in the community. They're going to work every day, but actively drinking as well. So we sort of just started looking at this Theta ERS measure in this group because they are actively drinking, right? So you would think, or we think, that we might see an even greater magnitude of effect in this group, right? Because they're actively drinking, right? As opposed to the short terms who recently had stopped drinking within the past 15 weeks or so, and then compared to the long terms who have been able to maintain abstinence for a long period of time, right? And as I mentioned before, we measured this measured theta ERS in relation to targets in an oddball task. Well, the oddball task is fairly easy. All the subjects do really well, right? And they don't differ, like groups don't differ on their performance, right? They all are fairly accurate with their responding to targets, and they all perform well and they don't perform differently. So we've actually just started collecting data on more demanding tasks. For instance, we have just implemented an in-back task, right, similar to the ones that have been shown in healthy non-clinical participants to be associated with theta ERS levels, right? So working memory load increases, theta ERS levels increase. So we thought that we should be able to better see this in a more demanding task, and also, is it possible that the effect in alcoholics could actually break down at some point if the working memory load becomes too high, right? Maybe because their theta ERS levels are already at a higher magnitude. At some point, would it break down, and we would see sort of regain their cognitive problems that had before that they were compensating for, right? And then, so the final point I would make is that so far, evidence has suggested that this may actually be a biomarker for use. So, in relation to what Kent was talking about, it could potentially be if we could translate that into being a marker for recovery of cognitive function after abstinence, or a marker of cognitive function after abstinence, or being able to even predict, right? That's another thing that we're working on, is using this measure to potentially predict those short-term abstinents who will go on to relapse, or the ones who will go on to become long-term abstinent alcoholics. It could potentially be it could be a sensitive measure of that, since we see changes, at least cross-sectionally, between long-term abstinent alcoholics and short-term abstinent alcoholics. It could potentially be a measure of recovery too, and also prediction of relapse. So that's some of the things that we're thinking about in relation to this measure. Got a lot more stuff, got a lot more work to do with it, but it seems to be promising. And with that, I'll thank you for your attention.
So Casey, I have two thoughts. One is much of your interpretation, and yesterday too, Jasmine said things change over time as compensatory mechanism. If you look at within your long-term alcoholics between 18 months and 10 years, if there's any change, because you think at 10 years maybe they're more like controlled.
Right.
And then the other thing I'll just say,
Okay, sure.
Did you explore the delta range at all? Because P3B especially is mostly delta. P3A is a combination of theta and delta. And I'm not sure about the ERS and delta, so I'm just wondering if you could explore that.
Sure, yeah, very, very good question. So in relation to the first question, there's no correlation between levels of data that led to synchronization and length of abstinence. So for instance, the long-term who've been abstinent 18 months, there's no correlation between length of abstinence. So another thought that we have is this may be a marker, not necessarily length of abstinence or the ability to maintain abstinence for long periods of time, but it may be a marker that alcoholics reach some level of drinking, right? So for instance, they reach a level of drinking that qualifies them to be deemed dependent, and then maybe it's related to that, right? Instead of necessarily being correlated to how long they've been drinking or how long they've been abstinent, it's just the fact that they reach a level of drinking that's heavy, that's reaches criteria. That's a thought that we have. We have to explore that more. That's a possibility. Right? The second part of your question about the delta, we did look at delta in the long-term abstinence, but the evoked delta, because it's the evoked delta that generally underlies the P3. There were no effects there. I have not looked at the induced delta, but I would expect there would be, but it would be something to explore.
From the fMRI, there were no correlations with abstinence also.
Okay, so you've looked at other contextual effects that happen in the oddball. So I'm curious if target-to-target interval might be something that is impaired in in, for example, the generation of a normal P3, because it obviously has a huge modulatory influence. Have you had a chance to look at anything like
I
that?
have not. Yeah, those are things that I have planned on looking at, but I have not looked at that. We also, all this was in relation to the targets, right? So I'm now looking at the standards, right? And it was a 3-condition oddball task. We have rare non-targets in there as well. Another interesting finding that I just found is that if you look at the theta-related synchronization, it's actually sort of composed of 2 parts, right? It's composed of pre-stimulus and the post-stimulus, right? It's a ratio of the 2. So it could be the fact that one part of that is deficient in alcoholics, right? So if you look at and in fact, there are indications that maybe the treatment-naïves and the short-term alcoholics may have lower pre-stimulus values, but then higher ratios, right? Which suggests that they start off with lower pre-stimulus values, which is associated with what's called cognitive readiness, right? So they're sort of anticipating upcoming stimuli, right? They're deficient in that, so they compensate more by having, which is indexed by a higher ratio, right, opposed to pre-stimulus. Whereas the controls in the long terms don't have that. Right? It's just sort of stuff we're coming across that could potentially be important to relate to.
And do you think there's specificity for this with respect to alcoholics, or do you think that you would find it in any addiction?
Well, P3 has found a lot of things, so
right.
That's a good question. I would expect it's probably not. I don't know. I won't say. I haven't looked at it, so I don't know. But since P3 is pretty, you find a lot of different things. You may find this as well in different things. But it's definitely worth exploring.
But we do have long-term abstinent alcoholics with drug comorbid. Those are not included.
Yeah, all these were alcohol only, right? They didn't meet dependence for any other things. We also have groups who have concomitant drug dependence. So that's another group we could look at to see if it affects it.
Right, well, as we talked about last night, just because they don't meet for dependence for anything else doesn't mean they're not set up or have the same biology as someone who develops an addiction for environmental reasons you might not have access to or see or would have,
Right.
especially on an island.
Yeah. There's a lot of stuff on islands. Yeah.
Getting back to the point about the fact that these short-term alcoholics there might be a subset of these that have a lower theta, but then go on to be long-term alcoholics. Have you looked at all at correlations with things like risky decision-making, impulsivity?
I haven't looked at this is all new stuff, so that's definitely on the list of things to do. Right. I have looked at this in relation to like other cognitive measures we have, working memory tasks, and it doesn't correlate with those, but I expect that. I would expect that's maybe just because it's not this task, right? So that's why we're recording these things in relation to impact tasks and more demanding working memory tasks. So we'll have the ERPs to those tasks, right? But yeah, that's definitely something that would be important to look at. Thank you very much.
Thanks, everyone.